Hey, welcome. Today we're jumping into a concept that we all use every single day, probably without even thinking about it: perimeter. Now, this is way more than just a term from your math class. It's the secret sauce for fencing a yard, framing a picture, or even planning a running track. Let's dive in.
Okay, so picture this. You want to build a classic white picket fence for a yard just like this one. The very first question you've got to ask yourself is, how much fencing do I actually need to buy? And that question right there is all about perimeter. It's just the total distance around the outside of a space. And hey, it's not just for fences, right? The same exact question pops up if you're wrapping a gift and need to know how much ribbon to use, or if you're putting a fancy border around a room. These are all perimeter problems in disguise, and today we're going to crack the code on how to solve them. All right, so before we get into the tricky stuff, let's make sure we're all on the same page. What exactly are we talking about when we say perimeter? So the textbook definition might sound a little stuffy, but the idea behind it is super simple. Just imagine you're taking a walk along the very edge of a shape. The total distance you walk, that's the perimeter. It doesn't matter if it's a perfect square or a weird, wacky plot of land, the rule is always the same. You just add up all the outside edges. Now, while you could always just walk around and add up every single side, who's got time for that? For common shapes, there are some really handy shortcuts. Let's open up our basic toolkit. For square, since all four sides are the same, you just take the length of one side and multiply it by 4. Easy. For a rectangle, you add one long side, the length, and one short side, the breadth, and then just double it. And for any old triangle, well, you just add up its 3 sides. These formulas aren't magic, they're just a faster way to get the job done. Okay, that was the warm-up, but what happens when we start sticking shapes together? This is where it gets really interesting, and where a lot of people fall into a classic trap. Let's call it the composite figure puzzle. All right, check this out. We've got 2 identical rectangles. Using our formula from before, the perimeter of each one is 5 plus 2, which is 7, times 2, gives us 14 centimeters apiece. So far, so good. So, logically, you might think that if you join them, the total perimeter would just be 14 plus 14, which is 28 centimeters. Makes sense, right? Well, let's see. When we push these 2 rectangles together to make one new, bigger shape, something really important changes. So what do you think? Is the total distance around the new outside edge still 28 centimeters? The answer is a big, fat no. The new perimeter is actually 24 centimeters. Wait, what? Why? Because those sides that we push together are now on the inside of the new shape. They aren't part of the outer boundary anymore, which means we totally ignore them. And that is the absolute key to composite shapes.
This brings us to the golden rule, the one thing you have to remember. You absolutely cannot find the new perimeter by just adding up the old ones. It just doesn't work. You have to treat it like a brand new shape and only measure the new outer boundary. So, if adding them up is the wrong way, how do we get it right every time? Don't worry, it's actually a really simple 3-step process. Step 1. Forget about the inside lines and just identify the new outside edges. Step 2. Figure out how long each of those outside edges is. And step 3, you guessed it, just add them all up. That's really all there is to it. Let's put this to the test with an example. Check out this T shape. It's made of 2 rectangles, but we don't care about that. We only see a new shape with 6 distinct outer sides. Our only job is to add them all up. Okay, let's take a lap around the edge. We've got a side of 8, then a 4, another 4, a long base of 10, then we go up a side of 6, and a final side of 8. We add all of those together, and we get a total perimeter of 40 centimeters. See, no tricky formulas, just careful addition of the outside lines. All right, so this is great for solving problems in a textbook, but why does any of this actually matter? Let's look at a couple of real-world cases where this stuff is absolutely essential. Okay, take this paddy field. We're told the total perimeter, the fence line, is 130 meters, and we know its length is 40 meters. Using what we know about perimeter, we can actually work backwards to figure out the field's width. It's like being a detective for shapes. Or how about this playground? We know the track all the way around is 360 meters, and we're told the length is twice the breadth. This is a classic real-world puzzle. By setting up a little equation with our perimeter formula, you can find the exact dimensions of the playground. This is literally what surveyors and builders do every day. So, the big takeaway here is that perimeter isn't just some abstract idea, it's a fundamental, practical tool that we're using all the time. Whether you're doing a DIY project at home, laying out a garden, or working in construction, you're using the concept of perimeter.
So, I'll leave you with a little challenge. Now that you know the secret to finding the distance around any shape, no matter how weird it looks, take a look around you. What's the perimeter of the room you're in, or the desk you're sitting at? Once you start looking for it, you'll start seeing perimeter absolutely everywhere.